Okay, so these conditional probability questions require a little bit more attention and a little bit more thinking. Okay, so a test for a particular disease gives a 90% positive result for those who have the disease and give a negative result for the remaining 10%. Okay, now be careful in that first line. It gives a 90% positive for those who have the disease. So that means it's giving 10% of the people that have the disease a negative result. Okay. For those who do not have the disease, the test gives a positive result in 1% of cases. Okay, so false positive in 1% of the cases, and a negative result in the remaining 99% of the cases. From a large population in which only 0.2% have the disease, and remember 0.2% is 0.002, because we like to turn percentages into decimals. A person is selected at random and tested. If the test gives a positive result, okay, so that's the part that I know, okay, it gives a positive result. So probability A is that it gives pos result. Okay, what is the probability that the person selected actually has the disease? So probability B is that they actually have the disease. Now, we know that approximately 0.002, the probability of having the disease is 0.002, but that's not the question. The question says, if you're given a positive result, what's the probability that you actually have it? Okay, so what I'm actually looking for, okay, is, is the probability that you have the disease given that you have tested positive. Okay, so given that there's a positive test, so that's the one that I know, what's the probability that you actually have the disease? Okay, so I'm not looking for the probability of B, I'm looking for the probability of B given A, okay, given that there is a positive result. Okay, so I don't need to calculate this at all. I need to calculate the probability of A, because the probability of B given A is going to be the probability of A intersection B over the probability of A. Okay, so these are the two things that I need to calculate. Right, so let's look at what gives a positive result then. Okay, now the main reason you'd get a positive result, okay, is that 90%, okay, so 90% of the positive results, 90%, I'm just going to change 90% into a decimal, okay, 90% of the 0.2% that have the disease. Okay, so 0.9 times 0.002. Okay, or, okay, there is a slim chance, okay, that you can test positive. So the test gives a positive result in 1% of cases. Okay, so for those who do not have the disease, the test still gives a positive result in 1%. Okay, so that means for 1%, 0.01, of the people that don't have the disease. Now, if 0.002% have the disease, okay, we have, okay, times 0.98, okay, or 0.998, sorry, 0.998, sorry, I was doing that in my head. So that's the amount of people. So 0.002 have the disease, which must mean that 0.998 do not have the disease. Okay, so in 1% of the cases of people that don't have the disease, which is this here, okay, they're still testing positive. Okay, now or means plus, so calculate this, add it to this, and I get a probability of 0.01178. Okay, so this 0.1178 is the probability that you test positive, so PA. Okay, now that does not necessarily mean that it's a true positive, okay, but that's the probability that it tests positive, okay, true positive, and then this one here is what we call a false positive. Okay, now the probability of A intersection B. Okay, so this is the people that have the disease and test positive. So the probability of people that have the disease and test positive would be 0.002 have the disease, and the probability that they test positive is the 0.9. Okay, so if they have the disease, you're told here that there's a 90% positive. Okay, so that is 0.0018. Okay, and then I'm going back to my conditional probability. The probability that it tests positive, the probability that I have the disease given that I've tested positive. A intersection B is 0.0018 over the probability of A, and I've got 90 over 589, which is 15.28%. And I'm going to give my answer as a percent because the question was given as a percent. Okay, now I urge you to spend some time with this example. Okay, it is really, really important.